In my previous video, I illustrated how to carry out a factorial MANOVA in SPSS, and I had a set of independent variables, two categorical independent variables, intervention group and gender, and I had three dependent variables, self-efficacy, utility, and intrinsic motivation. And in that video, I was illustrating that when you run through SPSS, when you run the analysis, by default you get a set of between subjects tests, which are basically factorial ANOVAs, comparing the groups, are basically looking at main effects of each of your independent variables as well as the interaction on each of the separate dependent variables. And I stated that one option as a follow-up to the between subjects effects might be to carry out something like Tukey's post hoc tests. So, for instance, in that illustration, I had an intervention group. I actually had three intervention groups. There were only obviously two levels for gender, and so I ran Tukey's post hoc tests and compared each of the intervention groups. Down here, each of the intervention groups on each dependent variable. Now, if I want to unpack the interaction effects, so back up here where we see the interaction term and its relationship to each of the dependent variables, I stated in the previous video where I could describe those interactions just by going to the profile plots that I request in SPSS. So in the previous video, I illustrated looking at profile plots for the self-efficacy measure, looking at intervention group by gender, and essentially looking to see how the relationship between intervention group and self-efficacy changed across levels of gender. The same would go for the utility dependent variable and also for the intrinsic motivation variable. If I want statistical tests of these comparisons, say for intervention group A, and I want to compare males and females, and then intervention B comparing males and females, and C comparing males and females, for each of the dependent variables, I can actually do that. And those are basically what are referred to as simple effects tests. So if I want to ask for those types of tests, what I can do is I can go to Analyze, go back and basically go back into the multivariate option box and click on Paste, and then a syntax file will open up. And so what I basically would want to do is to go to the line that says e-means tables, and it's got the interaction term listed, intervention by gender. So what I can do is say, if I want to compare males and females between the different interaction groups, or rather within each of the interaction groups for each of the dependent variables, I can type in what is called a compare command. So I can say compare, and in the parenthesis I can type in gender, and then in parenthesis. And if I wanted to utilize some type of Bonferroni adjustment or something like that, I could easily do that. I could just type in ADJ Bonferroni, and I could certainly get Bonferroni adjusted tests in this comparison. So at any rate, when I run when I highlight everything, click on the green button and run it, again, all this other stuff is exactly the same, and what I'm basically trying to do is to kind of break down the interaction a little bit more as it relates to each of the dependent variables. So now I have a table of pairwise comparisons, and essentially you can see that for self-efficacy, within the intervention A group, I now have a comparison of males and females. So the mean difference is the I minus J means. So you can see that basically males would be scoring about 5 points lower on average than females when it comes to self-efficacy. Now, was that difference statistically significant? It appears to be so. So as your p-value is less than conventional threshold of 0.05. When I look at intervention B, so that was intervention A right there, there's the mean difference. When I look at comparing males and females, you can see that males scored 12 points higher on average than females, and that difference was also statistically significant. When I look at intervention group C, comparing these two groups, you can see that males scored about 2 points lower on average than females, but using the 0.05 threshold, that would not be significant, so that would be non-significant. When I look for the utility dependent variable, when I compare males and females, you can see that there was no mean difference, and obviously that was not statistically significant within intervention A. When I look in intervention B, with the comparison between males and females, there was a significant difference, with males scoring about 6 points higher on average than females. Within the intervention C group, when I compare the two groups, you can see that males are scoring about 2 points lower on average than females, and that difference was statistically significant. When I look at intrinsic motivation, when within the intervention A, when I compare males and females, you can see males are scoring 5 points lower on average than females, and that difference was statistically significant. Within intervention B, males are scoring about 12 points higher on average than females. That difference was significant. And within intervention C, males are scoring about 4 points lower on average, and that difference was significant. So, kind of breaking this down and going back and looking at the profile plots, remember that essentially males were lower than females in A, males were lower than females in B, but that difference was not significant, and males were higher males were lower in C, and that difference was not significant, but males were higher in B. So if we wanted to just kind of take a quick look at the profile plot, kind of replaying what we saw in the pairwise comparisons, we saw that, again, males were lower than females in intervention A, and that difference was significant. Males were higher than females on self-efficacy in intervention B, and that difference was significant. And then males were lower than females here in intervention C, and that difference was not statistically significant. Going a little bit further, and just kind of taking another look at utility, there was no difference between males and females in intervention A. You saw that males scored higher than females in B, and females scored higher than males in C, and both of those differences were significant. So kind of scrolling down and looking at our utility profile plot, you can see that there was no difference between males and females in intervention A. You can see males scoring higher than females in intervention B, and that difference was significant. And then you have in intervention C, males scoring lower than females, and that difference was significant. So the benefit of those types of tests is just that you can follow up and sort of further unpack what's happening with respect to the interaction. And these are, like I said, these are called simple effects tests.